In example 2, we're going to change the wording of this question slightly. We're going to, instead of write use, we're going to say without. It's a little bit of a different question then. Without a graphing calculator, comma, graph y equals log base 8 of x. Now, we've done some graphing of logarithms before. So this is a basic parent graph of logarithms. How do we graph logarithms? Well, I want to graph log base 8 of x. All logarithms, their parent graphs have an asymptote. Where is the asymptote for every single log graph? Is it vertical or is it horizontal? It's vertical at x equals 0. Every single parent log graph has one point that's the same. Doesn't matter if it's log base 8 of x, log base 3 of x, log base 3,000 of x. There's one point that's always on the parent graph of a log graph. What is that point? One comma 0. And then based on the base that you have, we have log base 8 of x. I need to figure out a nice number that I can plug in for x that I can figure out that logarithm. Remember, logarithms figure out exponents. So what number can I plug in for x so that I can say 8 to what exponent is? I need to plug in a number that works out nicely. If I plug in 8, 8 to what exponent is 8? 1. So you have, in this one we have 8 comma 1. But if you had a log base 3 of x, you'd have 3 comma 1. And the shape of our log graph, or any parent log graph, looks like this. So we can see that it doesn't have any y-intercepts. We've got our x-intercept labeled at 1 comma 0. We have our asymptote labeled at x equals 0. If we wanted to state the domain of any parent log graph is x is bigger than 0, and the range is everything.